Yes. What is relative motion? Today we'll be discussing relative motion, which is required for your class 11 physics. It is included in motion in 2 dimensions. I mean motion in a plane, chapter 4. Okay, after motion in 1D, we treat all the topics with the help of vector. I'll assume that all of you remember the concept of vector addition, unit vector, all these things. Okay, then discussion will be easier for us. Relative motion can be understood first using one-dimensional motion. So relative motion can be there in 1D, can be there in 2D, can be there in 3D also. What is relative motion? A relative motion in 1D, 2D, 3D all possible if we know what is the meaning of a relative position. Our discussion, let us start with the concept of a relative position. What is that? What is the concept of relative position? Suppose there is a origin where this is the origin of two-dimensional coordinate system. At the origin of two-dimensional coordinate system, the x coordinate is 0. We are trying to understand with the help of one dimension, and the concept of a relative position we will know first. Understanding of relative position is very important in understanding relative velocity. Okay? Relative position means with respect to one particle, the position of another particle to be discussed. This is our origin. Suppose a particle situated at the point A, whose distance from origin is equal to xa. Another particle situated at the point B, whose distance from origin is equal to xb. Okay? This xa is the relative position of the particle A with respect to the origin. xb stands for, xa is the position of particle with respect to the origin. Origin is at O. xb what? Position of particle, this is particle A, and position of particle B with respect to the origin at O. Okay? Then what is a relative position? Hope you all are ready with the pen and paper and start doing it with me. Relative position of the particle B with respect to the particle A is given by xba, which is nothing but xb minus xa. Okay? Relatively, the particle B is at a distance xb minus xa from the particle A. Okay? Now let us do one problem based on it to find the relative position. Like we are taking two persons standing here, A, B, they are standing here, and there is a car moving. There are two observers A and there are two observers P and Q with respect to observers are there. P and Q observers are there sitting on the car. Car is moving this way. Then point P moving with respect to A, point P moving with respect to B, Q moving with respect to A, Q is also moving with respect to B. But Q is not moving with respect to P, isn't it? Suppose the distance from A to B is equal to 20 meter, and from A to P this is equal to 60 meter. At an arbitrary instant, distance of Q, this person, is 80 meter, given this way. It's moving, but at this arbitrary instant we want to find this XPA. What will be the answer? This is nothing but XP minus XA. XP I have taken 60 meter. 60 meter minus 20 meter, that is 40 meter. What about XQB? This is XQ minus XB. XQ is how much? 80 meter minus, acha, XA is not 20, XA is 0. I'm sorry. It is with respect to B you can take. It is XA, no? XA is position. We are comparing with respect to XA only. So it will be 0. So this is also 60 minus 0, that is 60 meter. Here it will be X cube at a distance 80 meter minus XB 20 meter. Here 80 minus 20, that is 60 meter. Clear? A is the origin here, no? So position of P with respect to A 60 meter, position of Q with respect to B is 60 meter. Somebody asked you to find position of B with respect to P. How to write? It will be XB minus XP. Meaning of this is what? XBP stands for what? Position of B with respect to P. So XBP equal to XB minus XP. What is XB here? 20 meter, and XP is what? 60 meter. This is minus 20 meter. This is important. Negative. Position is negative with respect to P because it lies on left side. That's why. What is position of the point A with respect to Q? This will be XA minus X cube. How much is this? That is 0 minus 80. This is also minus 80 meter. Oh, sorry. This one will be minus 40. True. This is not. This is minus 40 meter. Alright. So this way we understand the relative position. Now what is relative velocity? We are going to define first. Let us do it in one dimension, then in two dimension. Relative velocity. Relative velocity, I told you, we will be discussing in 1D, in 2D, In 3D we will just solve problem by using the concept. We will not draw any diagram or we will not solve 3D problem exactly. Just some vector problem. With the help of vector we will do it. So in 1D, this is 1D motion only we have considered. So relative velocity in one dimension in 1D, relative velocity of particle B, it has no link with previous one, just we are defining phrase. Just we'll use this thing that XBA. XBA stands for what? XB minus XA. This will not forget. This will remember always. Relative velocity of particle B with respect to the particle A is given by VBA. This is nothing but rate of change of position of B with respect to A. So by using the concept of differentiation, you will say that it is ddt of what? Change of position of B, I mean relative position of B with respect to A, that is ddt of relative position of B with respect to A. But you know that relative position of B with respect to A is XBA, isn't it? This is what? This is ddt of XB minus XA. And relative velocity of B with respect to A will be writing by this symbol VBA. Maybe this ink is not suitable for you, I am changing it. I am writing VBA. Since velocity is a vector quantity, we will just put vector above it. But in 1D, we need not put it. Just rate of change of position will be enough. What is ddt of XB? This is VB. What is ddt of XA? This is VA. So VB minus VA. Okay. So relative velocity in 1D, therefore in 1D relative velocity of particle B with respect to A is given by VBA equal to, right now we will not put vector sign. 1D we need not use vector. Clear? We will just apply in solving sum. So if you can define relative velocity of B with respect to A, why not relative acceleration? Relative acceleration of B with respect to A, this is also possible. How to apply it? Relative acceleration of B with respect to A, it will be ABA. ABA is nothing but AB minus A. Keep this thing in your mind. Okay? So we have done relative position, we have done relative velocity, we have done relative acceleration. Let us apply one by one in solving. I showed you already problem on relative position. Let us do it with velocity. Okay? So relative velocity actually means what? Relative velocity means change of displacement in 1 second. VB stands for what? Velocity of B. VA stands for what? Velocity of A. But velocity means displacement in 1 second. So displacement of B in 1 second minus displacement of A in 1 second. that is relative velocity. This simple concept keep in your mind. Okay, so if I give you one example this manner, there are two objects or two particles, whatever you say, A going this way with velocity 10 meter per second, B going this way with velocity 15 meter per second. This is situation 1. You will be writing VBA and VAB both before I write it here. Clear? And number 2, same thing, only A going towards right with 10 meter per second, B is going towards left with 15 meter per second. Your problem is to find VBA and VAB. Okay, we want to write VBA and VAB. So in the first case, if we write VBA will be VB minus VA. So 15 minus 10 meter per second, this is nothing but 5 meter per second. What about this thing? VAB is 10 meter per second minus 15 meter per second minus 5 meter per second. So in the first case, it is velocity of what? Velocity of approach or velocity of separation? What is that? If it is positive, if VBA positive, it is velocity of separation. If VAB negative, then it is velocity of approach. Why? A is approaching, A is lagging behind B, A is going towards B. That's why it is velocity of approach. So you can write a note over there. If, and this will be true for other cases also, if VBA, note, if VBA greater than 0, this implies VBA is the velocity of separation. VAB less than 0, this implies it is velocity of approach. Okay, let us find velocity of separation or velocity of approach in this case. Let us write see here they are moving in opposite direction. If we want to write VAB, this will be what? VA minus VB. But towards right, velocity in 1D we take positive, along displacement positive, it is positive. 10 minus 15. This is 25. Okay, this is separating, and here VBA will be what? Minus 15 minus 10. This is minus 25. Clear? So this part minus 25. Now let us solve some practical problems on it. Practical problem means we will be discussing the lift problem. In lift, if a projectile thrown vertically upward, lift is accelerating upward, then what will be the time of flight and what is the maximum height? This can be solved nicely with the help of this relative velocity or relative acceleration. Okay, so the topic we are naming like this: relative acceleration, relative acceleration in a lift. Relative acceleration in a lift. Lift is going upward with acceleration a. Stone is thrown from a stone is thrown from here in upward direction. Okay, suppose it is thrown with velocity u. This is your lift. This is the lift. Stone is thrown upward with velocity u. Your problem is to find the time of flight. This problem we can solve with the help of relative acceleration. What is the relative acceleration here? Lift. Acceleration of the lift with respect to what? Ground. Will be what? Acceleration, because this lift, I mean gravitational acceleration acting downward, no? So this will be a minus g, a plus g, isn't it? Acceleration of lift with respect to the ground, that is a plus g. I mean relative acceleration, because when you or you write, you will understand better, you write a lift with respect to what? A lift with respect to the ball. Ball is thrown upward. You write ALB. Don't say this thing. You write ALB. ALB is what? AL minus AB. What is A lift? AB is what? Minus G, because G is vertically downward. So acceleration will be A plus G. Clear? Now, time of flight means the time taken by it to strike the ground, to strike the floor of the lift. So, how do you get it? For time of flight, we'll be using this relation S equal to what? U relative into T minus half A relative into T square. Okay, S relative, but S relative will be what? It has no displacement with respect to the lift, it will touch the ground again, but S relative equal to 0. So 0 equal to U relative T half A relative T square. U relative into T equal to half A relative into T square. Isn't it? T and T getting cancelled. So T is going to be twice U relative by A relative. What is U relative? Tell. Ball you have thrown, lift is not thrown. Lift's initial velocity is not there, it is 0, it is just accelerating. So U relative what? U minus 0. U ball with respect to U relative means U ball with respect to left. A relative we found, that is A plus G. Okay? So time of flight going to be T equal to twice U by A plus G. Never forget this. Clear? Now can you write all the equations for motion here? Will you try to write? Let us find the maximum height first. How to get the maximum height? Before that we write all the equations of motion. Okay? So equations of motion we write. Equations of motion in case of uniform relative acceleration. Okay, simple, you all can write it. That v equal to u plus at, you know. So first equation what to write here? V relative equal to u relative plus half a relative t square. Okay, we have used already. The second one we have used already. S relative what? Tell. S equal to ut plus half a t square. It will be u relative into t, small t, because for time of flight we take big T. Here it will be small t plus half a relative into t square, and then v relative square equal to u relative square plus v square equal to u square plus 2as, you remember. So u square plus 2as, we'll write 2 a relative into what? That will be s relative. Okay, clear? V square equal to u square plus 2as. I am going to set one problem here. Acha, before that, let us learn one more thing. What is the maximum height of the projectile over there? That we haven't done. I left it because these equation of motions were not ready in case of relative motion. Can you write in the lift problem what is the maximum height acquired by the projectile? Can you find it? Maximum height above the floor of the lift. Relatively you are doing, there will be no confusion. Okay, relative will help you everything. With respect to floor of the lift, what is the relative height? That will find. That's why equation I am checking, it is S relative. This S relative will find. Okay. So the situation you try to remember, lift is there, lift going up with acceleration a, ball is thrown with velocity u, and acceleration due to gravity of the ball is under the control of gravity. Lift cannot control, it is inside lift in air. So lift acceleration has no effect on it. So what going to happen over there? There, that at the maximum height, you will write at the maximum height, no v relative is left. V relative will be equal to 0. So this implies 0 square equal to what is u relative? U relative is what? U ball minus u lift. No. U ball minus u lift. Lift has no velocity, it is u minus 0, u only. So 0 square equal to u square plus what? A relative what will I write? Tell. You are considering ball's motion. So we will take acceleration positive or negative. What you are going to find? That height will be upward and relative acceleration is downward, isn't it? So u square minus 2 a plus g into h. H stands for S relative, because both are in motion, nothing is fixed. With respect to lift of the floor, it will arise up to what distance? H will be equal to u square by twice a plus g. Very important. Never forget this concept, these equations of motion. Okay, these are star problems. star equations of motion over there. Okay. So relative motion, maximum height, understood. Now we are going for what? We are going, this is done in 1D only. In 2D coming now. In 2D many cases are there in relative motion. Okay. First let us define relative motion in 2 dimension. How to define that? They are moving in different directions. So it is relative motion in 2D. We'll be discussing these cases here. These many cases here. Number one is what? That is the definition part. Okay. We'll define, then application in riverboat problem, then application in rain man problem, and another application there, application in air and plane problem. Okay, this we have to know with clearer concept. Okay, I think you're feeling cold. Asank, it's okay. If you are not comfortable with this bench, you can sit over there. Okay. So let us do one by one. Definition first. Relative motion in 2D. What I told you, in case of 2D, we will be just replacing all those by vector. In 2D, already you have the idea. In case of motion in 2D, what is the displacement vector? Position vector of A and position vector of B. This position vector we take, say, RA, and this one RB. Then what is displacement vector? Displacement vector is AB. How to write AB vector? AB vector by triangle law, OB minus OA, isn't it? Here we will not write X or Y separately, we will write RB minus RA. This is called what? This is called displacement vector. Okay. Now their velocities are uniform. In 2D, how to find the displacement between two particles after a certain time? How to get it? With this, you will not get. You need to get velocity. So rate of change of this displacement is required. So this is AB, means position vector of B minus position vector of A. How the relative position of B with respect to A is changing, I mean that rate of change of position we are interested to find. That will be given by VAB or VBA. Okay. So this is what? AB, then relative position of A with respect to B, or B with respect to A. Which one true? AB is what? We have taken displacement vector. Position of B minus position of A. Actually, we have denoted this thing by RBA. There is no contradiction. It is AB vector. What's in it? But symbolically, it is RBA. RBA means what? RBA stands for relative position of B with respect to A. Clear? This is relative position of B with respect to A. RBA. So relative position of A with respect to B, how will you write? RAB, isn't it? RAB will be what? RA minus RB. There is no confusion in it. This is relative position of A with respect to B. And we will define relative velocity the same manner we did before. What is that? Relative velocity of, let us define this first. B with respect to A. How will I write? It is VBA. VBA stands for what? VB minus VA. How did you get it? How did you get this thing? VB minus VA? It will come from displacement. At first I show you how did you get it. That VBA by definition is what? I am deriving it, that relation. VBA by definition is what? VBA equal to velocity of B with respect to A. This is a rate of change of what? Rate of change of position of B with respect to A, isn't it? So this is what? Rate of change of position of B with respect to A. This thing is ddt of what? RBA. ddt of RB minus RA. So ddt of RB minus ddt of RA. This is what? VB minus VA. Clear? If you are interested in proving that also, I did here. It is rate of change of position of B with respect to A. That is VBA. VAB similarly. VAB is what? You can derive also. It is VA minus VB. But this time you should keep in your mind this calculation will be vectorial. Vectorially. This calculation should be done vectorially. Scalarly, if you do, it will be wrong. I'll show you why and how to apply. So, the question, if I ask you, the question already I have asked you. Suppose somebody given just a question with you. Let, I have collected many questions I have, but I am not going there. Simple question. With these simple questions, you understand the topic first. Let VA equal to 2I plus 3J. VB equal to 4I plus 2J. Okay? Your problem is to find RBA after 10 seconds. All these are in meter per second. Velocities are given in meter per second. You find their position, I mean relative position of B with respect to A after 10 seconds. See how nicely it can be solved now. Because you all know derivative. You have the idea of vector subtraction. IJ representation is there. We can do it nicely. So let me answer this. What will I do? I'll find VBA. VBA, not VAB. VBA is VB minus VA. mean B with respect to A moving with this relative velocity, which is vector subtraction, that is 2I minus j, isn't it? So what will be RBA? How to find RBA? It will be VBA into T. Am I correct? It's all right. That VBA going to be RBA going to be VBA into T. Relative velocity of B with respect to A multiplied by time. So this is going to be 2I minus j into 10. So 20I minus 10j. You find mod of this to get the actual value of the distance. This is nothing but root 20 square plus 10 square, that is 500. This is nothing but 10 root 5 meter per second. Okay. Clear? I'll show you one more example. In 1D it is very easy, just subtract, direct subtraction. But in 2D, let us take another problem. Oh sorry, distance will be in meter. Extremely sorry, it will be meter. Correct. Now next one, we are going to solve this problem. Particle going towards right with velocity say 4 meter per second. In 10 seconds, its velocity changed towards north 3 meter per second. Okay. So this is east. A particle going towards east with velocity 4 meter per second and towards east I said, and then after 10 seconds it's moving, this is north, moving towards north with velocity 3 meter per second. Okay. Now the question is find the change in velocity. Here only one particle involved. Find the change in velocity and number 2 acceleration produced. Can you find? It was 4 meter per second, then in 10 seconds it changes to towards north 3 meter per second. Then what will be the change in velocity? See, when you are answering this kind of question, there is a very important concept. What is the concept? If you want to treat with vector, I will show you two different methods. If you want to do it with vector ijk, you know a vector can be slid parallel to itself. Towards north means along x-axis. This is what? 4i. This is your V1. Am I correct? What is V2? This V2 I will be taking from here. Okay? Or okay, you don't take here. If you are confused, you don't take here. You take it here only. What is this V2? Tell? 3J. Because it is along y-axis. So V2 minus V1 is what? Three j minus 4I. Del V is this. So therefore change in velocity is what? Mod of 3j minus 4y. Clear? This is root over 3 square plus 4 square, that is 5, taking in meter and second. Clear? Change in velocity found. So acceleration will be what? 5 divided by 10 meter per second square. Clear? People can ask you this question also. If the mass of the body is 2 kilogram, what is the force required? Someone has done this. It is going towards right, towards east with 4. Who changed? It is towards north suddenly. Someone has done it. What's the force he has applied? It will be mass into acceleration. Clear? Understand? Now, problem will be there if it is given that particle going towards northeast and then suddenly towards south. What will be change of velocity? That we will discuss in problem, but keep this concept in your mind. Okay? And I am going to tell you how vector triangle law can help it to get directly the result in any complicated cases. Okay? So this is theoretical discussion I am going to do now, which you can remember the method to find VBA using, not using IJK, just using vector, using triangle law, better to say, or parallelogram law. Okay, parallelogram law. This is important. This you must remember. To find VBA using parallelogram law. One very important thing I would like to tell you. Whenever you are going to find relative position, you assume that one body is at rest, the other is moving. Relative other is at some position with respect to that. When you say the relative position of B with respect to A is 13 1D, we will assume that A is at origin, then B is at 30 meter away from it. When you say the relative velocity of B with respect to A something 5 meter per second, we will assume that A is at rest, B is moving. Understand what I said? You can assume that A is, one of them is at rest and the other is moving. So to find VBA using parallelogram law, we can assume that A at rest, B is moving. Okay, so what will be the concept? Let me write that part first, where you have understood the definition of VBA. VBA is what? Vectorially, it is VB minus VA. Okay, one particle is going, this I will do purely by vector method where no IJ is considered, without using IJ, by using parallelogram law. This is the direction of VA, this is direction of VB. Okay, you revise vector concept also. What you want to find? What you are going to find? VB minus VA. So VBA you can write this way also. VB plus minus VA. Remember in parallelogram law what you did? You found R equal to P plus Q. Then their resultant mod R you found. No, this is what? P square Q square minus or plus? Plus 2PQ cos theta. This thing. This is for what? This is for triangle law, parallelogram law, whatever you apply, resultant will have this form. And tan alpha is what? Just remind you, Q sin theta by P plus Q cos theta. We might have got in terms of A and B. Formula is same. Now we have to find VB plus minus VA. What will you do? Minus VA is not there, it is VA. So we have to get minus VA. What will I do? We'll add minus VA to this. Okay? So to get this thing, we add minus VA. Minus VA will be in what direction? Opposite to the vector A. Minus VA will be opposite to the vector A. Now VB vector is there, minus VA vector is there. You complete the parallelogram now. Okay? So this procedure, to keep in your mind, I am writing here. We add minus VA with VA so that the particle A is at rest. So that it seems that particle A is at rest. Only B is moving. So VA is there, we have added minus VA. Now this is what? R equal to P plus Q, when you have taken P along one side and Q along the other side of parallelogram. Complete the parallelogram and diagonally represent the resultant. We will apply the same method. But where is the parallelogram? We have to frame the parallelogram. Done? Parallelogram is done. So their resultant, what is the resultant here? Resultant in what direction? This is B, this is A, this is C. This diagonal will represent the sum of these two velocities. Isn't it? This way you get VBA. And if I take the angle theta, can you tell me what is the value of this resultant and what angle it makes with? B, VB or VA? This angle be alpha. We can write this value of alpha. How? First you write the value of VBA. What is that? Here you are doing without IJK method. IJK is sometimes inconvenient. This method works nicely. So how do I write mod VBA? Tell, by resultant formula only, that mod R equal to, mod R no, this is what? Mod VBA equal to what? VB square VA square clear? Just in this formula you substitute, then you will get. Okay? And what is the angle? Let VBA makes an angle alpha with what? Alpha with, okay, you take alpha with what? Okay, alpha with minus B, no problem. Alpha with minus B. Then tan alpha will be what? Tan alpha will be VB sin theta by VA plus VB cos theta. Don't take any negative sign. Okay? With this formula, you can nicely get the resultant. So if you can apply IJK concept, you do. If you can apply this concept, you do. There is no problem. So two methods I have discussed. Finding relative velocity. Okay? Now, this concept of relative motion we can apply in several cases. I am just going to tell you in case of rain and man problem. Man, very old man like me, just walking on ground and it started raining. How much speed can I move? Say maximum 5 centimeter per, no, 5 centimeter. So, okay, assume 5 meter per second I can make. 5 meter per second. Okay. Drops of rain are falling vertically with 10 meter per second. If I hold the umbrella this manner, what is your idea? I get wet. Because drops of rain, when I start moving, if the drops of rain falling vertically downward, I am standing stationary here. I hold the umbrella this manner, no problem. But as soon as I start running or moving, drops of rain will appear some other direction. Why? It will be relative velocity of rain with respect to me. You replace me by a man. So I am going to apply it in solving the rain problem. How to protect? How can a man protect himself or herself from the rain? Okay. So how will I name this problem? This problem I name as rain and man problem. So you pose the problem this manner. Drops of rain are falling vertically downward. Drops of rain are falling vertically downward with velocity Vr. Man moving with velocity Vm horizontally. Okay. In what direction he should hold the umbrella to protect from the rain? My answer is to protect himself or herself from the rain, he should hold the umbrella along VRM. Clear? He should hold the umbrella along VRM. Am I clear? That is relative velocity of rain with respect to the man. So I explained just by using the diagram, the concept vector subtraction we got. What is VRM by definition? Tell. VRM is VR minus VM, isn't it? So you add minus VM this way. You add minus VM this way. Clear? Now what do you have to do? You have to complete the parallelogram. Okay? Then in what direction he should hold the umbrella? Man going this way. Umbrella he has to hold this manner. If he holds the umbrella this manner, he get wet. Or straight, he get wet. So you have to get the direction of VRM. VRM will be in what direction? VRM will be diagonal of the parallelogram. Okay? This is VRM. Clear? So man should hold the umbrella this manner. I am trying to draw the umbrella here. He should hold the umbrella this manner. This manner, isn't it? To protect himself from the rain. This is umbrella. This direction rain was appearing because VRM this way, this angle be theta. Can you tell me how to get this theta? If I have given you VR and VM, how to get this theta? This vector triangle in figure, tan theta will be what? Tell. This is perpendicular and this is base. Simple. VRM, VM by VR. No negative positive. Therefore, theta equal to what? This I told you last session. Shift tan and then put this thing inside. You will get the angle. Clear? This is one way. This we are approaching rain problem one way. There is another way definitely. Okay, that method also I am writing. Then I will show you one numerical example. Then the concept is clear. Okay, just let us do it. Let us do this thing by using vector. Vector means this is also vector, that is also vector. But this vector I haven't used ij. Now I am going to use ij method. Okay. So you write, you name this method alternative 1, aliter. Drops of rain are falling vertically downward. This is VR. This is mathematical. And this you will not do any mistake here, I am sure. There also you will not do mistake. If you like vector, definitely you will try by that method also. So I will go by definition and the data given. If you are taking this way, suppose I have chosen x-axis this manner. This is the x-axis and the vertical direction as y-axis. Don't forget the rain problem by drawing x and y-axis. This you are doing just to solve the problem. How to find VRM? VRM will be VR minus VM, isn't it? But VR I can write by using vector. What is the unit vector in that direction? I cap. This way minus j cap. This way j cap. That's why it is minus j cap. I need not draw parallelogram. No parallelogram is required. Only this presentation now. I will remove arrow from VR. I will be writing minus VRJ and minus VM I. Finished. This is done. Now VRM will be what? Mod. Mod you know very well. It is VR square plus VM square and theta will go where? That you have to understand. If it is minus VR minus VM, that portion lying here, no? That vector will lie here in this quadrant. In this quadrant both are negative. So it will be something like this. You consider magnitude only. This is theta, this is theta. Tan theta is what? Minus VM by minus VR, take mod. Never take negative sign. Same thing. Tan inverse VM by VR. When you are solving practical problem, you do the way you are comfortable. Concept lies here. Clear? Now, I will be discussing all the cases for rain problem, how to tackle. This is one way of tackling rain problem. How to, this session will be finished with this because we will do sums based on it. Then we will start boat and boatman problem in the next session. So let us do one problem. This if I give you some, you will simply solve it by using formula. There is no confusion in it. But I am here to discuss the method so that you can solve any problem I am going to ask. So let us solve a problem here with that concept. with respect to, write the question this manner, with respect to a man moving towards east with velocity 10 meter per second, drops of rain appear to fall at an angle appear to fall at an angle. I'm just taking simplified case. Drops of rain appear to fall vertically downward, not at an angle. Appear to fall downward, vertically downward, same thing. Downward with velocity 5 meter per second. When a man moving towards east with velocity 10 meter per second, the drops of rain appear to fall downward with velocity 5 meter per second. Find the actual velocity of rain. You have to find the actual velocity of rain. This is different from the previous one. Man moving towards east with velocity 10 meter per second, drops of rain appear to fall downward with velocity 5 meter per second. Find the actual velocity of rain. So you have to write what is given over there, and let us solve this one by IJ method first. Okay, IJ method. What is given here? VM. VM is what? Man going towards east with 10 meter per second. So this is 10I. What is VRM? It is minus 10G. You agree or not? This is VM and they said it is going vertically downward. So this is minus 5J. Sorry, this is not 10. This is not 10. I have given minus 5J. Take it minus 5J. So this is minus 5J. VRM given. What is your problem? Find VR. We want to find VR here. Answer. See, I am answering this question. I will be simply writing VRM. Means what? VR minus VM. So VR is what? VM plus VRM. VM is what? 10I. VRM is what? Minus 5J. Finished. So VR I got. I need not find anything else. Why? Because a vector AI plus BJ gives everything. Isn't it? So this is 10I minus 5J. What will be direction? Can you tell me? Just without any calculation. Where does this vector lie? 10 comma minus 5. Where does it lie? It lies in fourth quadrant. 10 comma minus 5. So it will be directed, not exactly, but this manner. How will I refer this direction? This is east, south, north. Okay, no, this north south is no, this is vertically upward, vertically downward. Okay, north south I haven't told. This is west. So this angle can be stated here by using this concept only. This angle will be what? VR, this 10 minus 5, 10 this way minus 5 this way. So tan theta will be 5 by 10. That is half. So this angle theta means this one also theta. Theta equal to tan inverse half. Okay? So I hope you have understood the concept of relative motion. তাই তো? ঠিক আছে তো? বোঝা গেছে? একটানা বললাম দরকার ছিল, কিন্তু এটা খুব কনসেপচুয়াল জায়গা। এটা যদি বুঝো তোমার ক্লাস 12 এ যখন এন্ট্রান্স দিতে যাবো অনেক হেল্প করবে, আর নোটটা থাকুক সঙ্গে। ঠিক আছে? আস্তে আস্তে পড়লাম তো, অসুবিধা নেই তো? ঠিক আছে? হ্যাঁ, কোথায়?
আগের বার স্যার tan থিটা স্যার vm বাই ur যেটা পেলেন থিটা
এটা?
হ্যাঁ স্যার।
হ্যাঁ
এইটা কি হয়েছে সেটা করে বলে দেবেন?
হ্যাঁ বলে দিচ্ছি। দেখো এইটা vm, তার মানে মাইনাস vm তো এদিকে আছে। এই ট্রায়াঙ্গেলটা করে নাও, এই প্যারালোগ্রাম, এই ট্রায়াঙ্গেল, তাহলে এটা vm, এটা মাইনাস vm মানে এটাও মাইনাস vm, এটা vr, তাহলে tan থিটা কি হবে? vm বাই vr। ঠিক আছে? হলো? বুঝতে পেরেছো? একটা দুটো প্রবলেম দিই নাকি? আজকে আমি কিছু জেরক্স এনে নিই, এনসিইআরটিতে নেই সেরকম ভালো প্রবলেম নেই, আমি বলে দিচ্ছি প্রবলেম।
এটা কিসের সিনারিও ছিল স্যার?
হ্যাঁ,
এইটা যে করেছে
উইথ দ্য ভার্টিক্যাল, এই যে
এখানে ম্যান আর রেন,
এটাও তো রেন অ্যান্ড ম্যান প্রবলেমই করেছি। বোর্ডস তো ধরিনি এখন, অল্টারনেটিভ মেথড অ্যালিটা লিখে রাখলাম না, ওই জন্য মনটা দিয়ে রাখতে হবে তোমাকে, রেন ম্যান প্রবলেমে দিয়ে অল্টারনেটিভ মেথড। এটা জাস্ট মানে ভেক্টরিয়ালি করেছি, এটা আইজেকে দিয়ে করেছি, আর কিছু না, একই জিনিস। বললাম যে একটা এক্সাক্ট সাম করো, ডিসি কোয়ান্টিটি থেকে দিই। Right. To a man working 3 km/h, the rain appears to fall vertically. When he increases his speed to 6 km/h, it appears to meet him at an angle of 45 degree with the vertical. Find the speed of rain. করবে, ট্রাই করবে, দেখো।